Guys, how are you today? So today I'll be solving the physics AMS of term 2 week 6. I'm very sorry for the late video because I was studying for my IGs. So basically what I noticed in this quiz is that you have two questions that are repeating, so I'm just going to go very fast for this. Consider the velocity time graph of a toy car shown below. They want the magnitude of the car's acceleration. Okay, magnitude, very important keyword. That means whatever answer we get, we're going to put it in absolute value of the car's acceleration at a specific time. That means they are looking for what? The instantaneous acceleration. In order to find the instantaneous acceleration, you will need to find the slope of the line and put it in absolute value because they want the magnitude. So just choose any 2 points. For example, this point over here and this point over here. This is 2, 0.5 and 1, 1. So to find the slope, you're going to do y minus y over... my bad, I did it wrong. Wait. It's 0.52 and 1, 1. So you're going to do y minus y over x minus x. So 2 minus 1 over 0.5 minus 1. You will put it on your calculator and you're going to get what? Minus 2 meters per second squared. But you have to put it in what? Absolute value. So to put it in absolute value, you are going to get 2 meters per second squared. We move on to question number 2. In question number 2, it says... Okay, sorry for that, my internet was lagging. So consider below the position time graph of a descending drone. They need what? The magnitude of the drone's velocity. Now here we're not dealing with a speed time graph, we're dealing with a position time graph. So the slope of the graph is going to be what? It's going to be the velocity. Magnitude again means you're going to take it in absolute value. So the magnitude of the drone's velocity at time 2 seconds is... So you're just going to choose 2 points. Okay, just choose 2 very clear points. For example, this point over here, which is 0.20, and this point over here, which is 2.15. They're 2 very clear points. And then find the slope. To find the slope, you're going to do y minus y, so 20 minus 15, over x minus x over 0 minus 2. You're going to get minus 2.5 meters per second, because we're dealing with speed, but they need it in absolute value, so it's going to be 2.5 meters per second. We move on to the next question, question number 3. This is going to take forever to load. Okay, there we go. A car initially moving at 30 meters per second decelerates to 5 meters per second in 3.8 seconds. Okay, very important keywords you should know about. Okay, deceleration means that it will decrease its speed. Acceleration means it's going to increase its speeds. But let us see first of all what we're going to get. They want the acceleration of the car. If they want the acceleration of the car, you're going to do velocity final minus velocity initial. So velocity final is 5 minus the velocity initial, which is 30, over the time, which is 3.8 seconds. You're going to put it on your calculator. You'll get approximately minus 6.6 meters per second squared. But here's the catch. They said acceleration. If they say acceleration, we will take it negative. If, however, they said deceleration, then you will take it what? You will take it positive. But since it's acceleration, you're going to take it as minus 6.6. We move on to question number 4. Question number 4, the diagram below shows the variation of a car's velocity with time and the tangent to the curve at time t 10 seconds. What's the instantaneous acceleration of the car at time t 10 seconds? As we said, to find the instantaneous acceleration of anything, you need to find the slope of the tangent. So let us find the slope of the tangent together. Just take 2 points. For example, choose the point 40, 15 and the point over here, which is what? Which is 10, 5. And then to find the slope, you're going to do y minus y over x minus x. So 15 minus 5 over 40 minus 10. This is going to give you 1 over 3, which is what? Which is 0.33 meter per second squared. So like that, we found the instantaneous acceleration of the car at time 10 seconds. Now the graph below shows 3 runners completed a 100-meter race. Which runner won the race? Definitely the person who wins the race will complete the distance in the shortest amount of time. So the shortest amount of time out of all of them is definitely 12 seconds, which belongs to who? It belongs to Albert. So Albert won the race. Which runner stopped for a rest? You can look over here and you can see if the slope is 0 or it's a flat line to the distance, that means he did not move. If he did not move, it means he took a rest. So definitely it's going to be Charlie. So Charlie took a rest. Move on to question number 6. In question number 6, it says, the distance time graph shown below represents the motion of a toy car along a horizontal axis. Okay, they want the time interval during which the toy car is at rest. If the toy car is at rest, that means what? That means it's not moving. That means it has a fixed distance or a fixed position. Which is the only place that has a fixed distance or a fixed position? It is this place over here, which is what? From 0 seconds to 3 seconds. So, as you can see, the time of the rest was what? Was from 0 seconds to 3 seconds. Now, the farthest point from the origin the toy car reaches, where is the origin? The origin is over here. Okay, so the farthest point that they reach from the origin, this line over here, just look at which is the farthest distance from the origin, and you will see that it is at this position, which is what? Which is 10 meters. The net displacement of the toy car. How do we find the net displacement of the toy car? It's very simply what? The final position, which is 10 meters, minus the initial position, which if you count, okay, let's say each one is 2, so it's going to be 2, 4, 6, 8, 10. Okay? So, from 10 till 6, so final position minus initial position, 10 minus 6, that's going to be 4 meters. So, the displacement is going to be what? It is going to be 4 meters. Okay, the total distance traveled by the toy car. How do we calculate the total distance traveled by the toy car? Just very simply add. So, here it's not moving anything. We will not consider it. Then we will take its position from here. This is 6 meters. From 6 meters, it goes all the way down to what? To minus 4 meters. Okay? So the total distance traveled from here to here, it is what? It is 6 minus 4 meters, which is what? Which is 10 meters. Now the next thing that happens is that from this position over here, which is minus 4 meters, until this position over here, which is 0 meters, okay? Please do not forget always to take the absolute value of the answer. So from minus 4, you're going to take minus 4 minus 0, so you're going to get minus 4. Take it in absolute value to get 4 meters. So now we have 10 plus 4, okay? Now the next thing is, how much did he move from here until here? You're just going to see the distance. You will see that it is what? It is 10 meters. So 10 plus 4 plus 10, this is going to be what? This is going to be 24 meters. The toy car is at the origin at instances. Where do you see that the toy car is at the origin? At this point and this point. This point over here is 6 seconds. And this point over here is about 13 seconds. So the times and where it's at the origin is at 6 seconds and 13 seconds. We move on to question number 7, not 8, 7. The distance time graph shown below represents the motion of a particle moving along a horizontal axis. The net displacement of the particle over the course of 30 seconds. So how do we find the net displacement? As we said before, you will take the final position, which in this case, I can assume that it is 4, and you will subtract it from the original position, which is 0. So 4 minus 0, you will get what? The net displacement, which is 4 meters. We move on to part 2, the total distance traveled by the particle over the course of 30 seconds. Okay, now this one is interesting. The total distance traveled over the course of 30 seconds. From here till here, he moved what? A distance of 20 meters. From here to here, he moved a distance of what? Of also 20 meters. So you have to take it in the absolute value. From here till here, he moved a distance of what? Of 8 meters. You guys need to know how to use your graphs correctly. You can know that each block here is what? 4, based on the divisions. So 20 divided by 1, 2, 3, 4, 5. Each block is going to be 4. So if it's 2 blocks, it's going to be 8 meters. Here he did not move anything. Okay. Then from here all the way till here. So it's going to be from this position over here, which we can say is minus 8. And this position over here, which we can say is 4. So the total distance is 4 minus 8, which is 12 meters. So now we have what? We have 20 meters up plus 20 meters down plus 8 meters down plus what? Plus 12 meters up. You will add them all together to get a total distance of 60. Okay, so 60 meters. The average velocity of the particle in the time interval 0 seconds, 14 seconds. Okay, so very simply, They want what? They want the average velocity. In order to find the average velocity, you will need to find what? You will need to find the displacement of the particle. So if this is 10, so 11, 12, 13, 14, no. Okay, so that means each block is 2. That means this is 12, this is 14. So this position over here is 14. So to find the net displacement, you're gonna take this position over here, which is minus 8 meters, and you're gonna, my bad, and you're gonna subtract it from the original position, the first very initial position, which is 0 meters. So minus 8 minus 0, you're gonna get minus 8 meters is the displacement. And now in order to find the velocity, it's gonna be the displacement over time, so minus 8 over 14, and it will give you an approximate answer of minus 0.57. So minus 0.57. We move on to part 2, the average speed of the particle in the time interval. Okay, sorry, my voice keeps on cracking. Average speed is different than average velocity. Average velocity is what? Is the displacement over the time. Whereas average speed is what? Average speed is the distance over the time. That means if this point over here is 14 seconds, we'll need to find the total distance traveled in the 14 seconds. So from here till here, it's 20 meters. From here till here, it's gonna be what? It's gonna be 28 meters. So in total, it was traveled 20 meters plus 28 meters. It does not matter the direction, positive or negative. You're gonna get what? 48 meters. Okay, you're gonna divide it by the total time, which is 14. So 48 over 14, you're gonna get 3.43. So very simply, it's gonna be 3.43 to 2 decimal places meter per second. We move on to question number 8. Hopefully my internet will work. There we go. The graph xt shown below represents the motion of a particle moving along a horizontal axis. Okay, part A. They said the moment of time when the particle is instantaneously at rest. What does it mean? Instantaneously at rest means that its position is the same. It's not moving. So you just have to find the place where if you draw a tangent, it will be a straight horizontal line. That means its distance is not moving. Very simply, it's going to be this point over here, which is what? Which is 5 seconds. That means that 5 seconds, the tangent to the curve is a horizontal line. That means the distance is not changing. That means what? The moment of time where a particle is instantaneously at rest is 5 seconds. At time 11 seconds, the approximate instantaneous velocity of the particle. So at time 11 seconds, we'll need to draw the tangent from 11. So please do not mind my drawing, because I'm drawing on my tablet. So something like this. Hold on, let me try to draw it much better. I don't know. Okay, so I fixed my tangent. I think you guys could draw it more accurately in the exam, hopefully. So this is what your tangent is supposed to look like, and you're supposed to take 2 accurate points. For me, the 2 accurate points I chose is this point over here, which is 820, and this point over here, which is this point over here, which is what? Which is 12 minus 4. So now I'll need to find the slope. In order to find the slope, you're just going to do y minus y over x minus x. So 20 minus 4 over 8 minus 12, you will get an answer of minus 6. So very simply, the answer is minus 6. Now at time 11 seconds, the approximate instantaneous speed, what you need to know is that instantaneous speed is equal to the absolute value of instantaneous velocity. So if it's minus 6, that means instantaneous speed is going to be absolute value of minus 6, which is what? Which is 6. Very simply, all you need to know. We move on to question number 9. Okay, very interesting. In the first leg of motion, a bicycle accelerates from rest. So let's draw it together. He accelerates from rest in positive direction at 1.5 meter per second for 6 seconds. So this is 6 seconds, 1.5 meter per second squared. Okay, then it decelerates to a full stop in 5 seconds. So if this is 6 seconds plus 5 seconds, this would be 11 seconds. Okay, but it's decelerating. So the magnitude of deceleration, so we need to find the magnitude of deceleration of the bicycle in the second leg of motion. Okay, in order to find this, look how we're gonna do it. We're first gonna take what? We're first gonna take the total speed that was traveled in the first 6 seconds. In order to find the total speed traveled by the first 6 seconds, you're going to do the acceleration times the time. So acceleration is 1.5 meter per second squared times the time, which is 6. You're going to get 9 meter per second. Now, what's interesting is that you're decreasing, you're going down by 9 meters. So it's going to, by 9 meters per second. So it's going to be minus 9 meter per second going down, because you're going to reach to what? To a full stop over the time, which is 5 seconds. But don't forget, they want magnitude. So you will put it in the absolute value. So putting it in the absolute value, you're going to get 1.8 meter per second squared. So as you can see, it's not the same rate of deceleration. However, it is 1.8 meter per second squared. Drag and drop the correct answers to complete the table below that describes the sign of acceleration in each of the following. So the bicycle speeds up in a positive direction. You know that the acceleration is going to be a positive number, so it's going to be greater than 0. It slows down in a positive direction. That means it's two opposing. So pay attention. If there are two going, so look, speeds up. This is positive in a positive direction. Two positives will give you a positive. Slows down in a positive direction. So negative and positive, positive and negative will give you a negative value. So the acceleration is negative. However, speeds up, this is positive, in a negative direction, minus. So two opposite, positive and negative, they will give us a negative value. So the acceleration is going to be negative. And then finally, it slows down in a negative direction. That means negative and negative. So negative and negative will make a positive. That means the acceleration is going to be positive. Just take it like this. Speed is positive. Speeds up. Positive. So if you multiply two positive numbers, you're going to get a positive number. Minus. Minus, you're going to get what? Minus plus, you're going to get a negative number. Plus. Minus, you're going to get negative. Minus, you're going to get what? A positive. So just take it like this. We move on to question number 10. In question number 10, it says, the velocity time graph below summarizes the motion of two cars, A and B. Okay, which car is moving faster at the start of the motion? So definitely the one with the steeper slope. The steeper slope means it is moving faster. So in this case, which car is moving faster? It's car A. Which car ends up farther from its starting point? So which car ends up moving a farther distance from its starting point? It's gonna be what? The one that is more stretched out. So more stretched, which in this case, as you can see, it can be car B, because look, it reached a specific position, okay, directly. But car B, as you can see, it's the same length of the line, but it did not what? It did not reach the point. That means for it to reach the point, it's gonna be more stretched out. So the one that's more stretched, or you can say the less steep slope, it's gonna be what? It's gonna be the one that ends up farther from its starting point. And which car has a greater magnitude of acceleration? It's definitely always the steeper one. Steeper means that slope is gonna be what? That slope is gonna be greater. If slope is greater, then what does it mean? That means that acceleration is greater. So what was their question? Which car experiences a greater magnitude of acceleration? It is gonna be car A. We move on to question number 11. Consider three cars A, B, C, all accelerating steadily at first and then continue their motion, okay, at a constant speed. So they told us the maximum speed of car A. How do you find the maximum speed of car A? You just look at the graph. Where does it stop increasing its speed? It stops at 30 meters per second. That means the maximum speed of the car is 30 meters per second. The distance traveled in car B while accelerating. What does it mean while accelerating? That means this position over here. Okay, what is this position over here? It is a triangle. So in order to find it, you need to do the base, which is 15, times the height, which is 20. So 15 times 20 divided by 2 meters. Assume that the car C has a greater acceleration than car A, but it reaches a lower constant speed than car B. Select the possible speed time graph that represents the motion of car C. So car C has a greater acceleration than car A. What does it mean? If it has a greater acceleration than car A, that means it has a steeper slope, okay? That means what? It's gonna be a steeper slope, my bad. It's gonna be a steeper slope, but it has to be less than 20 meters per second. So, which has a steeper slope and is less than 20 meters per second, it's gonna be the first graph. Guys, I feel like I'm explaining this all wrong. No, don't worry, I'm joking. I know what I'm explaining, it's just gonna take so much time, ya Allah. Okay. The acceleration time graph below shows the motion of an elevator initially at rest during 16 seconds. Okay. So, the acceleration at the elevator at 2 seconds. Oh my goodness. Just look at 2 seconds. See, this is the acceleration. It's gonna be 4. Very simple. The instantaneous velocity of the elevator at time 4 seconds. This is different. They need the instantaneous velocity. In order for us to find the instantaneous velocity, it's gonna be acceleration times time. So, where's the acceleration? Here, the acceleration at 4 seconds is what? Here. At 4 seconds, it is what? 4 meters per second squared. This is the acceleration. Multiplied by the time, which is 4 seconds, you're gonna get what? 16 meters per second. Very simple. Now, the displacement of the elevator at time equals 4 seconds. Okay, so remember that the equation for displacement x, it's equal to what? It's equal to the velocity initial times the time, multiplied by the time, plus what? 1/2 the acceleration times the time squared. But in this case, what's happening? You have that the velocity initial is 0. If velocity initial is 0, then you're gonna get that the x, or displacement, is equal to 1/2 times the acceleration times the time squared. So the acceleration at 4 seconds, you can go back to the graph and you can see it is what? It is 4 meters per second squared multiplied by the time squared. What is the time at what is the time? The time is 4 seconds, so times 4 squared. You're gonna put it on your calculator and you will get an answer of 32. So it's 1/2 times 4 squared. So the answer is 32 meters. The acceleration of the elevator at 10 seconds. So again, just go to 10 seconds and go down. You will see it is what? It is -4. I don't know, some of these you don't need to explain, but some others are very hard, okay? The instantaneous velocity of the elevator after 12 seconds. Okay, after 12 seconds. Okay, so at 12 seconds, it's what? It's -4, but after 12 seconds, it's what? What is the acceleration after 12 seconds? Acceleration is equal to 0 meters per second squared. But here's the thing. They want the instantaneous velocity. So the velocity is going to be acceleration times time. If acceleration is 0 and the time is 12, the time is the difference. So it's going to be 16 minus 12, which is 4. You're still going to get a difference of what? A difference of 0. Again, instantaneous velocity after 12. So if 12 is -4, after 12 it's gonna be until 16. So the difference in time is what? It is 4 seconds, okay? And the acceleration is what? It is 0 meters per second squared. So it's gonna be 0 times 4, which is then 0. Very simply, 0. Now, select the velocity time graph that correctly represents the motion of the elevator during 12 seconds. So, look, as you can see, at the time 2 seconds, it becomes what? 4 meters per second squared. So, at the time 2 seconds, the acceleration is 4 meters per second squared. That means the velocity at the time 2 seconds, it's gonna be 4 times 2, which is what? Which is 8. So that means the first thing you need to have is that at time 2, the velocity is 8. So let's go down. You need to find at time 2, at the time is 2 seconds. I'm just gonna say 2 seconds is over here. You will see that it is 8. So this is definitely something we are gonna choose. I think this is the answer. Let's continue. Then it says that at time 10 seconds, the acceleration is -4. That means at 10, the velocity is gonna be what? The velocity is gonna be the time, which is 10 times the acceleration, which is -4. So it's gonna be -40 meters per second squared. So you're gonna come over here. Okay, so then displacement of the elevator at time 4 seconds is 32 meters. Instantaneous velocity of the elevator at 4 seconds. Okay, let us try this. At 4 seconds, the velocity is supposed to be 16. So let's see, 4 is over here. As you can see, it is 16. So perfect. 4 is 16. That means this is more proof that this is the grass. Sorry, not the grass, the graph. The instantaneous velocity of the elevator after 12 seconds. So, after 12 seconds, it's supposed to be 0. Basically, just take the graph based on the information you have from above. Move on to question number 13. Okay, they want the particle is instantaneously at rest. When can you see that the particle is instantaneously at rest? This we're dealing with a what? A velocity and a velocity time graph. Okay, so the particle is gonna be at rest when its velocity is equal to 0. So the velocity is equal to 0 at 2 points, which is this point over here and this point over here. This is 8 seconds and this is 13 seconds. So at a time of 8 seconds and 13 seconds, the particle is at rest. The instantaneous acceleration of the particle at time 5 seconds to 1 decimal place. Okay, at 5 seconds, they drew for us the tangent. Thanks for them for drawing the tangent. You will just take 2 points. Usually I like to take the first and last point if they are the fixed points, okay? So this point over here, it is what? This point over here, it is 1, 7. And this point over here, it is what? It is 0, 12. So now let us find the slope together. It's gonna be y minus y, so 7 minus, actually my bad, wait. It is 12, 0. So you're gonna do y minus y. What's y minus y? It's gonna be 7 minus 0 over x minus x, 1 minus 12. Put it on your calculator, you're gonna get minus 0.6 meter per second squared. So the instantaneous acceleration is minus 0.6 meter per second squared. Question number 14, it says the equation of the velocity v is whatever. Okay, here what you're gonna do is you're gonna find the slope. How do you find the slope? You do ax plus b is equal to y. Let us find a together by finding the slope. Okay, you find the slope by taking 2 points. You can take the initial point and the final point. It does not matter. Okay, so here this point over here, it is what? It is 412. And this point over here, it is what? It is 0, 2. So we'll be finding the slope by doing y minus y over x minus x. So 12 minus 2 over 4 minus 0. Put it on your calculator, you will get an answer of 2.5. So now you have the slope a, which is 2.5. So 2.5x plus b is equal to y. Next thing you're gonna do is you're gonna choose a point. For example, I'm gonna choose the point 0, 2, and I will substitute it over here. So 2.5 times 0 plus b is equal to 2. That means b is equal to 2. That means our final equation is 2.5x plus 2 is equal to y. But here's the difference. You will first of all get rid of the y, and you will replace the x by t. So it becomes 2.5t plus 2. 2.5t plus 2. We move on to question number 15. Question number 15 says, what does it say? Waiting for it. Okay. The average acceleration of the dog during the first 5 seconds. So you will go to the 5 seconds. You will come over here. And they want what? They want the average acceleration of the dog. This we are dealing, I believe, with a velocity time graph. So in order to do that, you're going to take the final point and the initial point, and you will draw a tangent to them. Okay? So at the final point, what is this position over here? This position, it is what? It is 0, 2. So this position is 0, 2. And this position over here, it is what? It is minus, it's 5 minus 1. So 0, 2, 5, minus 1. Let's find the slope together because the acceleration is the slope of the VT graph. So it's going to be what? It's going to be minus 1 minus 2 over 5 minus 0, which is what? Minus 0.6 meter per second squared. So your answer is minus 0.6 meter per second squared. We move on to question number 16. Please load. Don't have time for this. Okay. They want the average velocity of the object in the intervals 1 second, 3 seconds, knowing that this is a position time graph. So you just need to find the slope. Okay? So let's find the slope together from 1 to 3. I don't think it's enough. Okay, just memorize 1 to 3. This is 1 and this is 3 over here. So at 3, it's 0.36. At 1, it's 0.11. So if you find the slope, which is what? Which is the velocity, it's going to be 6 minus 1. So y minus y over x minus x, 3 minus 1. You get 5 over 2, which is 2.5 meter per second. I feel like I did not explain this as well as I should have, but it's okay. It's just quick. This we did it before. Huh? Yeah, we did this same exact question. So remember, it's 0, 3. So two questions were repeated. This is one of them, 0, 3. 10 meters, 4 meters, 24 meters, and 6 seconds, 13 seconds. This is the exact same thing as the one before. I don't know why they repeated it. Question number 18. They want us to find what? The instantaneous acceleration at time 1 second, knowing that at 1 second, the velocity is 1 meter per second. Okay, so they gave us the tangent, thanks to them. So we have this point, which is given as 1, 1, and this point, as you can see, it is what it is, 10, not 10, it's 5, 10. Okay, so now you're going to find the slope by doing y minus y over x minus x. So it's 10 minus 1 is 9. 9 over 4 should give you an answer of 2.25. So very simply, our answer is what? 2.25 meter per second squared. 19, they repeated this question, so it's the exact same one. So it's going to be 1.8. And here, remember, speeds up positive, it's going to be greater than 0. Slows down positive, it's going to be less than 0 because slows down is decreasing, so negative. Positive is positive, so they're opposing, they're going to give us a negative value. So plus and minus, speeds up and negative is going to give us a negative value. And then minus and minus is going to give us a positive value. So let's submit. Hopefully we don't have any mistakes because I'm not. And perfect, no mistakes. So thank you guys for watching. I hope you enjoyed and have a wonderful day.